Welcome to AI DIY. Thank you so much, gentlemen, for joining today for our discussion. Super excited for episode 2 and coming together again this week to dive into RAG, or Retrieval Augmented Generation. So, in this episode, we're going to talk about what is RAG and why it's necessary for new generative AI applications. We're going to do a bit of a hands-on demo, courtesy of OC here, walking us through Bougie PT and some of what Ori.dev has been working on. And after that, we're really going to focus on how you can get started with AI through RAG processes, talk about the different types of RAG, as well as just explore some of the broader questions that are emerging in this new wave of technology. So thanks for being here, everybody. Really excited to have you all.
Hey, thanks for having us again.
RAG is a really cool technique to kind of level up LLMs from their baseline of what we're used to from stuff like ChatGPT, where it can talk really good, but not necessarily provide you with useful facts a lot of the time, to something that is a lot more knowledgeable and has something that's approaching something that we might call memory, so much so that OpenAI even called their RAG-based features memory.
Metaphor that I like, which is that if you're just talking to, say, a chatbot or basically an LLM, you're really kind of just like talking to a person you met off the street, and they have some Latin knowledge. They have some stuff that they learned back in school and stuff like that and all that. But, they're not going to know what happened since they started taking their walk and met up with you, right? And they're also going to have some limitations on that. Now, imagine you're talking with that same person, but you're sitting at a library and there's a librarian behind the reference desk. And when you ask that person a question, now they can actually go and check, and that reference librarian can get them the information that they need to give you a good answer. So it's not just the knowledge that they're bringing off the street, it's also the knowledge that they have available in the library around them that's being brought to them, retrieved for them by the librarian.
So why is this necessary for those of our new listeners? Maybe they're just getting started with generative AI and LLMs, and they busted open like the API assistant or the OpenAI assistant, right? For example, why is RAG necessary? What's important about it for our listeners or for any engineer that needs to know?
Yeah, so I'm gonna go first if that's cool. I didn't really ask. So I would say that like the biggest thing that LLMs do that is a huge problem is that they're really hard to figure out, or it's actually impossible to figure out what is causing them to come to the conclusion that they're coming to, other than their training data itself. So you kind of assume that what they're saying is like a subset of that training data or some combination of it. But in that regard, like a lot of the problem, and this is commonly referred to as hallucinating. These hallucinations is where it seemingly makes stuff up because it's like imagining things about your data, or it's expanding on a concept that you didn't really tell it to, etc. Or it was trained on even incorrect data. And those hallucination problems, I think, are very, very strongly combated by RAG itself, which I think is like the biggest strength about it. I don't think it eliminates it entirely, but it makes it possible to actually prevent it and have a strategy in place to stop it.
And another point, the way I understand it is giving it more context, and like the models are trained on all the data on the internet. And so like really honing it in, and if you want to learn something specific about a specific topic, you have to feed it documents, and that kind of narrows the context and the scope of what that's what retrieval is it's retrieving that specific data for you. So giving it the context it needs to correctly answer you is also an important part of RAG.
So I want to ask a follow-up question. Maybe Uche and OC, you'll have a perspective on this. We're saying that we want to add to the context window, or that we're trying to add more information to the LLMs. But to the lay person, generally they, when we describe it as LLMs have been trained on sort of all knowledge, the entire internet. Is it really about adding to the context window, or are we biasing, our systems? Is it about weighting them? Like, how do you think about it in those ways? OC, Uche, what are your thoughts there?
Yeah, I can I can talk to that a bit. I like to think of LLMs as they're really basic parts, which, like you said, is not the way that I think that we oftentimes don't talk about them this way, and that can be very confusing. But LLMs at their basic level just they predict language, and then they predict the next bit of language after that, and the next bit of language after that, word by word, technically token by token, if you're getting technical about it. And they do that based on the training set that we discussed, and that training set does contain some information that we might want to get out of the LLM. If there's certain facts, the sky is, and that sentence always ends with blue, then the LLM knows that the sky is should always end with blue. But it doesn't really know that inherently. For example, if you were on, let's say, Venus, the sky is not really blue there, it's a peach color. And the LLM, without the contextual knowledge of that situation, isn't going to know you're talking about Venus. And so it's still going to say the sky is blue. The sky is blue. That's always how that sentence goes. The sky is blue, even though here on Venus, the sky should be peach colored. And so when with RAG, we generally add that context in. We might tell the LLM before it answers the user's question, you are on Venus. Venus has a very dense atmosphere full of a lot of chemicals that generally produce a peachish color, and the LLM would then agree with the user when asked what color is the sky and say, the sky is peach colored here on Venus.
Right.
Yeah.
I just wanted to kind of expand on that too, is like the core innovation of LLMs, in my opinion, is really truly just that they have like mastered a competency of language in a way that is unprecedented in human history, which is crazy. But basically, like that core thing is that they understand language and they're able to predict what's going to be next, right? They don't truly understand it. So I guess that's kind of a philosophical question. But like their ability to like handle that language is really like the core crux of like, what do I have to tell them to do, right? So I think that like an example I've been using a lot is like reading comprehension tests that we used to take in school. So you used to have to take these tests where you'd read a story, right? And then you have a series of questions about it. And some of the questions actually say like on line 5 and line 7, these two things are being written and being compared. Like, what do you think about this, right? And on that reading comprehension test, you would go to line 5, go to line 7, and you'd read it, and you could literally answer the question without reading the story sometimes, right? But there's lots of questions where you have to read the whole story if it's about like 3 or 4 different characters that were in it, right? And so you could kind of think of RAG as being like, how do you tell the LLM what lines to look at in this story, if that makes sense?
That does make sense. Uche, I think you have a great like high level summary of RAG being, I love your definition of it that you shared of any means of adding relevant information from other sources that the LLM can utilize. And so maybe Uche, if you wouldn't mind, I'd love to hear from you about sort of important ways to approach RAG in terms of when should we think about using it, or from your perspective, what's really important? Like, what's like the 15% of this podcast that our viewers need to remember related to RAG?
Right. Yeah, no, that makes sense. And yeah, I think, as you said, RAG is taking any information from somewhere else, putting it into the prompt so that now the LLM can work with that plus its latent knowledge, right? So there used to be a time when you couldn't really put a lot into a prompt. Maybe people who were early in ChatGPT could remember. Now you can put like whole books and stuff like that into the prompt. So that's called a bigger context window. So that's important. That's actually expanded where RAG can be used. It used to be that RAG was a really limited technique because of that narrow context window, i.e. how much can you tell an LLM at one time. Now it's broader. And so I think that actually changes how we think about what's a good time to use RAG and think about it. How is it different from other levels of doing things? A lot of people, like when they start working with large language models, they want to fine tune or train their own large language model. That's often not necessary because usually if you ask them why are you trying to do that, they'll say, well, this large language model, knows all the stuff that crawled in the internet, but it doesn't know about our corporate policies that we're trying to build to a chatbot for a user. Well, one way of doing it is, yes, you can fine tune it with a lot of that. Although it turns out from a technical perspective, that doesn't actually work so well. Adding knowledge and fine tuning and adding more training to an LLM does really weird things. So sometimes a safer first step, and definitely a cheaper first step and an easier first step that requires much less hardcore mathematics and engineering, is RAG, which is where you go ahead and take those corporate policies or whatever documentation you want, and then you feed it in with the LLM as it's answering questions or responding to prompts. So yeah. So high level.
Yeah.
So something I want to ask you all, we're all contributing to client projects. We're building with these generative AI LLMs. And I'm curious, as we've heard the benefits that we've expressed about RAG, sometimes I find that our clients, look at RAG as like, that's the only thing we need, right? We just need to get our data. We need to talk to our data. But I'm curious, when we talk about reducing hallucinations, sometimes that could set some misaligned expectations with our client. So how do we really think about, and this is an open question, whoever wants to take it, how do we really think about what it means to reduce hallucinations within a reasonable limit? Or how do you set that kind of clarity with someone that you're working with or working for? Like, what does it mean to actually reduce hallucinations to a significant level? Or where's the line?
Right. So I think that the first thing I would say too is that I think this question's a lot more philosophical than you think.
Oh yeah, I wasn't trying to.
I don't think we need to go down that. I don't think we need to go down that road. So one thing I was going to say too is that in the past, the way apps were done in common parlance was that you would use a structured database, right? And a structured database is going to be like a traditional SQL database where it has tables that have maybe entity relationships to other like foreign keys, etc. And it has some loose or not loose. It's actually very strict associations, right, between different data and different things like that. Well, like a core part of RAG that I think we've actually left out so far is that it's actually a confluence of like two technologies or two technological paradigms in a sense, right? Like there's LLMs and then there's also vector databases, which like are related but not exactly the same. They're tied together through this concept called embeddings, where in the development of these LLMs, basically what they were able to do is map human language to like a coordinate space, so almost geometry. So there's basically like these geometric equations that they could use to determine this. These are hard words, by the way. Semantic relevance. It sounds like I'm reading them. It's just a hard word. Semantic relevance, right? Of meaning like that. If I search for Apple, right, in a traditional structured database, like if I type the word Apple, it's just going to return only things that say the word APPLE, right?
Yeah.
But with a semantic database, it actually might return back other types of things like bananas or blueberries or strawberries because it's able to make the semantic connection that they're each fruit, right? And that concept right there, like fits different types of data better, if that makes sense. So kind of tying back to the original question, like I think that a huge issue we have between like reducing hallucinations and not is that a lot of people don't understand that their data might not be structured, like it might be too structured in a way that prevents easy derivative of semantic meaning in the prompts. So like it's hard to figure out what the heck you're talking about if the data is just an Excel spreadsheet, right? Like humans work the same way, in my opinion.
Because like to kind of simplify that for the listeners is like traditional structured databases are two-dimensional. And when we're looking at vector databases, which is where we put the embeddings to be able to bring down our resources, those are now three-dimensional. So like Apple would be somewhere in Cartesian space, the XYZ coordinates, and then banana would probably be right next to it because it's also related. So it kind of gives us a lot more control over where we're storing our data. And I'm sure the other guys can expand on that more.
I think that like the math portion of it is like it basically maps language to map, but it feels like wildly unpredictable, but like very they're not easy, but like you could usually figure out after what happened how the LLM got to a certain position. So like through one of our projects, Chris and I had to do a RAG pipeline, and we were running a search on it, and we searched for, I want to say like a document that was numbered like 1812 or something.
Yeah.
And it returned back like the top 3 results were documents about the education system in England. And I was like, well, I guess they were in the War of 1812.
No,
like,
I
is
said
that the
you were
semantic
like,
relation?
why is it returning stuff on England? I said probably because the War of 1812, and then it's like
I was like,
totally
okay.
unrelated.
So sometimes it draws those connections, like when you don't expect, but all of that does fundamentally map to like rigorous mathematical rules that you don't necessarily have to understand to utilize the full power of these pipelines. Or
Yeah.
arguably nobody understands as
Yeah.
well. That's the philosophical part, in my opinion.
And it's worth mentioning that it's not really a panacea to hallucinations or confabulations or whatever you call it when the LLM is basically saying things that it shouldn't be saying from the perspective of the product need. But it's a help because what you're doing is you're giving it some, like I said, like some information from the library to say, here's some information, construct your language from that. However, it can still sometimes read the stuff that's coming in from RAG in the prompt that was pulled in from the vector database, and it can still go off the rails. So it's not a magic bullet, and that's why there are many variations and layers that people have developed on top of RAG, which we'll probably touch on a little bit later, which allow you to kind of tune things and then eventually get it to the point where at least the level of hallucinations is low enough for whatever your goals are.
Right. Yeah, and that's kind of, I think, really the impetus of my question is to kind of bring us back to like what problem is RAG really solving? And I think positioning it only as a mechanism of reducing hallucination sets us up for poorly aligned expectations as engineers or creators, as well as our clients. Ultimately, we're trying to solve business problems.
Right.
And so I'm curious, before we move on to the demo, I definitely want to give OC a chance to walk us through a real life kind of example from Ori.dev. And so, but the last point here, just coming back to that question of like, what is it actually for then? If we know hallucinations are still a problem, we know the AI still can sort of go off on those tangents and sort of make semantic relationships that we may not have intended. If you had to think about it, maybe just like short, kind of round the horn. Like, what is RAG really for?
Can I expand? I know you're facilitating, but can I expand on that just a little bit with a quote I wrote down that I thought maybe this will come up, and I'll just pose it as part of that question for us to answer. Is I was listening to Andrej Karpathy, I think is how you pronounce his name. He is everywhere, so I don't remember where he said this or where I heard it, but I listened to him a lot. So one of the things he said was that LLMs, like, yes, they hallucinate, but they hallucinate all the time. Like, they never know what they're talking about. And like what RAG is, or the benefit of vector databases really, is that it allows you to actually combat and actually have a way to have truth to compare your LLM to, right? So it's not really a question of like reducing them. It's literally the only way that you can stop them at all in a lot of contexts, or even know if they exist is actually a more fundamental question. And so like along those lines, like, is everything a hallucination is something I would add to that as like a concept.
So I think that we've kind of covered that base. We've kind of we've beaten around that bush a little bit, but I think that in general I would describe RAG as a way to add context, add specific context to an LLM's completion. Anybody who's spoken to an LLM, especially about a subject that they're particularly knowledgeable about, will often find that the LLM quickly runs out of apparent expertise relative to what it seems to be confident about, and it really quickly starts running into those hallucinations. But not just reducing those hallucinations, but also increasing the depth of apparent knowledge with which the LLM can speak is a big part of why we do RAG a lot of the time. One of the examples of something of a neat way that we've used that, that I personally use that, in fact, is whenever I read a scientific paper these days, I run it through RAG and then an LLM completion, and I read the scientific paper, and then I start asking the LLM, which has retrieval augmented generation on that paper, questions about the paper, and it's able to answer my very specific questions because it's also reading bits and pieces of the paper along with me whenever I ask it one of those questions. So adding context is, I think, the primary thing we get out of RAG.
Awesome.
Yeah, and I think that actually kind of leads to another sort of pragmatic use of RAG. Is sometimes you have like stuff, old documentation, etc., that might no longer seem that useful because no one wants to read it end to end because of that little nugget on page 234. RAG is actually a useful way to keep it relevant, because what you do is you feed it into the machine, and then as you're going along, whatever, maybe it was a manual for like some old car you're restoring, right? And you just have a question while in the process of restoring the car, you put it into the LLM, which is fed in that old manual, and lo and behold, it pulls out that answer from 253 that this is the nut that you have to tighten under this other, widget. So that's it's a way to resurrect, old documentation into contemporary context. And just to give it one more little quick metaphor on how I see RAG from the perspective of, what does it really, what's it for? I think if you think about what an LLM is doing, it's taking all the information was trained on a whole bunch of Latin knowledge, mostly pulled from the internet, and it's kind of chopping it up into bits and feeding it to you, in a way that it thinks is relevant to the specific prompt that you've given it. So the problem is what you actually want in that prompt is not always in that big, massive training data it got. So RAG is a way to add some little snippets from something that's closer to what you actually care about, the specific context you're interested in, put that into the mix so that the LLM is feeding you little bits of that as well.
I think that's great. And I think that's a great summary of what we've been discussing so far. And for those of you that have joined in the audience, I just want to reiterate that we've spent the first part of the podcast talking about what is RAG, Retrieval Augmented Generation, talking about why it's important, and some of the experiences that we're having with it. And now at this point, I'd like to hand it over to OC to walk us through just a real example of how RAG can be used and how relatively simple it is to embark on this journey. That being said, we won't cover every type of RAG. Really, we could have a multi-episode series about the subject, even getting into tokenization, embeddings in more detail, all kinds of details. But, what I love about the podcast and doing this with you all is that we're really focused on getting hands-on. And so I'm excited to give OC the spotlight for a bit, walk us through screen share, talk about how to employ RAG in a simple way. And for the audience members, feel free to chime in the chat, in the live stream chat, if you have any questions. And I'll be helping provide OC some questions. But also, OC, I would encourage you at certain points as you're going through your flow, if there's anything that you want to ask us, right? Let's talk about it and keep it conversational as we go. So, OC, if you want to share your screen and take it away, would love to see what you're working on.
And I like Alexandra Liss's from the comments, speaking of mentioning that RAG also extends into some interesting like e-commerce search and product discovery, which is really interesting because a lot of the way that some of these RAG techniques started and were innovated from was from search techniques that are based around semantic stuff. So that connection is very vivid to me. But let's move on to that. Let's move on to that presentation. So let's see. Here we go. So here's the screen. This demo is actually over on if you go over to oori.dev, just oori.dev, and then you head over to our GitHub at the top here. You can find our ObuGBT. You can find ObuGBT here, and you can go to demo. And then in here is a PG Vector notebook, PG Vector under demo notebook, which you can run yourself. You can run this right side by side with us if you're curious about it yourself. That being said, moving on to said demo, we're going to go look at it in VS Code instead. So this is as discussed, this is a very, very simple demo. This is only going to go through the absolute basics of how a semantic search works. It doesn't even go into how to embed those into an LLM query, because this is, as discussed, a very deep field, and we're gonna have a lot to talk about even once we've gotten through this. But yeah, to start out with, specifically, this is going to be using Postgres with the PG vector extension, which allows us to store high dimensional vectors. It was mentioned earlier that vectors get up into 3-dimensional space, and in fact, we're going to be using an LLM, or we're going to be using a embedding model, which is a small LLM, which takes us up to 768 dimensions. And so this PG vector extension will help us do that. So initially, we're going to set that up with a bunch of imports and set up our database connection. I have this running on a local Docker container. And then using Hugging Face's sentence transformer library, we're going to import the all mini LM L6 v2. That's a embedding model, which is going to take the words that we provided, turn them into the embeddings that Keith mentioned, and those are going to get inserted up into the database. So we can go ahead and look at the document that we're going to embed, which is a slightly dated at this point meme about the FitnessGram pacer test. Anybody my age will remember this from school, having to run across their gym. And we've separated it into a bunch of lines, but that's another step where you can certainly go a lot further, is exactly how you separate out your text into different sections. You might want to separate it, if it's a novel, by chapters. You might want to separate those chapters into their individual paragraphs instead of being so granular as we are being here with sentences. But for a demo, this is a good way to demo things, in my opinion. And then we're going to create a connection to the database using this ObuGPT library here. This is a pretty simple connection. There's nothing crazy happening on the SQL in the back here, but I'm going to gloss over it because anybody who knows their SQL will be able to go interrogate that in the source code, and anybody who doesn't need to worry about that for now. We're going to real quick drop a table if one is found and create a new one so that we have one ready to go. And actually, let's be running these all so that we can actually see it in action. So, well, I guess we're not doing that because it has broken the something about the notebook. That's really annoying. I just had it working a second ago. Oh well. Luckily,
anyone who's used Python will understand and be sympathetic, man.
Luckily,
and I would have made that joke about any programming language, just to be fair.
Luckily, we still have the previous runnings of this, so we can go through those and still use those to understand it. But one thing to note about this whole process is that the whole thing just takes like under a second to run through all of these cells that we're discussing. So this is a very fast process, especially compared to what we're used to with LLMs. So once we've created a table, at that point, if we looked into our database with some sort of like a database examining tool, Adminer is my one of choice for Postgres, we would see a pacer table, which would contain a couple of columns for handling embeddings and text and stuff. We're going to go through on this next one. We're going to insert the document. So we're going to take this pacer copy pasta list, which was that list from up here, and we're going to go through each step of that as a for loop. So we're going to index them so that we know which line we're at. So once we've got our first line, we're going to insert it with this insert with this insert method here. We're going to put in the content as text, and that's going to get passed through the sentence transformer E model here. And that's going to turn that into those high dimensional embeddings that it will be eventually searched against. And then we're also going to include some metadata about it. This metadata can be used then later when the LLM is seeing that information that you've retrieved in order to give contextual information, such as Uche was discussing, you might include the page numbers of where to find that information such that the LLM can say, this information was on page X, and then the user can actually go and look and check for themselves on page X, so that they can essentially, the LLM can essentially cite its sources. Once it's done that, it's going to say that it inserted that many chunks into the table, and sure enough, it inserted 7 chunks, the length of that list, paste or copy paste into the table. Then we can immediately take that and similarity search the document that we're doing there. So now we're going to do a perfect match here. We're going to match one of these sentences exactly. That is a sentence straight out of the embedding that we were looking at, the document that we were looking at up here. And when we do a search for that using this search method here, what we're going to see is that we're going to return, and the limit is 3, but it's only returning 1 right now. No, it returns 3 down here. Yeah, semantic searching using string. Sorry, it's been a minute since I've gone through this demo. And it's going to return 3 examples here. And we're going to look at this first example, and it is a 1.0 cosine similarity. That means that it was a dead perfect match. So this search that we searched with gave us a perfect match, which gives us a 1.0 score. The content in that sentence that it found that matched it was this exact same sentence, and then we can see all the metadata is also included there. We get back the returned title in a few different formats, as well as the returned content. And now we can see, and we can also see some of the other things it returned, such as it returned the second time you fail to complete a thing, a lap before the sound, your test is over. When we look at that compared to this sentence, we can probably see why the cosine similarity is still relatively high, but not 1.0, not perfect. So this is an imperfect match with our query sentence, because you can see that it still has stuff like the word lap and the word completed and the laps being completed are both part of this part of these sentences. But then there's a lot of other stuff happening, like there's this beep at the start of the sentence. The second sentence talks about your test being over, and that probably contributes to why, instead of being a perfect match, this is only about a 68.5% match, 68.5 there. And then we have another even worse match down here, and these are getting returned in descending order, where this one was an even worse match because there's even less stuff related here. So generally, you're going to want to take the first match there, that number 1 match. But sometimes it might be useful to also collect stuff that seems slightly useful, because as we see in another example here with the partial match, if we only search for straight, we're going to get some different results that are a little bit more interesting now when we do this search. So we search and we get only a result with 28% similarity when we search, and what we get back is the sentence "ding, remember to run in a straight line and run as long as possible." And there we can see almost certainly why we got this sentence as our return from search, because it has the word straight in it, which is the word that we were searching for. So even though that's not a very good match, the next matches were even worse. At only a 10% match was the test will begin on the word start, on your mark, get ready, start. Well, there's nothing about going in a straight or line about that or anything about straightness in that. So it's only a 10% match. Very low. And our next closest match was only a 8% match, it looks like. And here it's just, there's nothing related to the word straight here. So this makes a lot of sense to be the first result to get back from our search, because we were searching for straight. If we change this to direct, we would also almost certainly get this result as our first result, because straight and direct, as discussed with an earlier example, are very semantically similar. The word straight and the word direct mean very similar things, and so when they are embedded, they go to a very similar place in the embedding, and that means that their cosine similarity is going to be very similar on that.
So, see, I just want to nudge you along a little bit.
Yeah, are we going a bit slowly?
Yeah.
No worries, no worries. It's a
Okay,
bit. This
okay.
is definitely a bit of a dense technical demo. So yeah,
Can we ask questions instead?
yeah, totally, please.
Or can I ask a question? Um, so like, how does this work with like longer data like sources? So let's say I have particularly a book or like a longer PDF or like a file a file folder full of documents that need to be scanned or something, right? Whatever it is, whatever the format is that has more text, how is that typically handled?
Yeah, so as discussed earlier, this is a pretty short demo. This is a pretty short document that we're chunking that we're using here for our demo. But one thing that's not discussed in this demo is how to chunk your information, especially for longer information, because that is of itself its own whole large subject. Let's say that instead of just this short little list here, we've got a big, huge, you said a document. I like the example of a whole novel, right? Sometimes people do want to search for a whole novel or like a whole textbook or something, right? And in those cases, this is going to be a very long thing. The database will handle that just fine. Anybody who's worked with Postgres knows that the amount of text in a novel is not something that couldn't be contained inside of a database. But if you just put the whole thing in as one very long string, that's not useful to anybody. Instead, you have to chunk it, which is more specifically taking it and breaking it apart into several chunks, which are then stored individually across that database. And then you can search for those individual chunks and get back individual ones of those chunks. A way that if we were doing that novel or textbook example would be, for example, to chunk by chapters. That's probably how I would instinctively go about that. So grab each chapter, only grab that chapter, and then run that push that into the LLM. Push that into the database. Grab the next chapter, push that into the database. And
can I ask? So like if you did it by chapters, then you would have like in the metadata for that chunk, which is like the information, you could have like a chapter number, and that's how you would retrieve it.
Yeah, so there's a couple of different ways that we can use that metadata to help retrieve it. So one thing that I was gonna mention next was that we can use more complicated ways to retrieve it. One common way to do that is to only use the titles of a chapter. So you might use the chapter title as the thing that you put into the embedding. So you just get out the embedding for that chapter title, but then whenever you search for that and you get back that chapter title, it also, as the metadata, returns both what you were mentioning, the chapter number, and also, let's say page number, and also the book title, right? A whole bunch of useful information. And then it also includes the entire the contents of that chapter as well. And that way, if the title of your chapter, going to Uche's example, was replacing a wheel, and somebody asks, I need to change a tire on my car to the LLM that has this document in its RAG, then the search there would be for I want to replace a tire. The RAG would see the chapter title, wheel and tire maintenance, and those match up pretty closely. Wheel and tire, I want to replace this tire. Yeah, those are about similar. It would grab that chapter and all of that useful metadata we just talked about, retrieve that all to the LLM. The LLM would then look through that chapter and see, oh, here's the information about how to change a tire on this specific car, and tell that information to the user at that point.
Maybe you can wrap up by just so we talked a lot about chunking and the initial retrieval of the vector databases, but of course there's the generation part. Maybe you can skip forward to once you've gathered those matching chunks, what happens next?
Yeah, so this demo is actually pretty. We got, luckily y'all started asking questions right at the end of where the document embedding happened. The next section of the demo is just chat log embedding, which is a little bit, we generally handle it a little bit differently, but ultimately the principles are the same. And at that point, the demo is actually over. This demo doesn't cover how to put it into your LLM prompt, because that is its whole own section. But that being said, I think we all have a lot of experience with it. And I think we can talk to it a lot. This demo just doesn't cover it right here.
Yeah.
We can just talk through that.
Yeah, so I'll go ahead and close down the screen share, and we can discuss that. Oh no, the infinite
Oh, cool.
mirror.
I was gonna ask a question to you again too. It's like I've kind of been writing down like, as I understand it with RAG, it seems like there's really like 3 levers that you could dive deep into to like figure out how to customize it to your system, basically, right? And like it's basically like the chunking of the underlying data, or like how you vectorize it, right? Like how you decide to do that. And then the second one is like the vector similarity search that you choose, right? Or however you choose to do the searching over said vectors, right? And then the third one I think is the prompting, which is where you actually take the results of the vector search and run it against the LLM. And like that's the part you didn't cover, which makes sense, right? Okay.
Yeah, and that part is basically going to involve showing that information to the LLM at that point, in such a way that makes sense for the application at hand. So if you're showing it, you might say the user, you might then prompt the LLM, and this leans a bunch into prompt engineering. You might then prompt the LLM with the user has asked you a question about changing a tire. Here is some relevant information about the car that they are working on, that came from this manual on this page. And then there is a big block full of that whole chapter information that we talked about.
Right. I think of like, I totally think that I've thought like that was a great explanation, man.
Yeah,
That's like a way better way to describe it than I was thinking about.
Because
Because I think like a big thing to call out there too is that like there's types of data that fit this type of prompting model better, if that makes sense. So like a lot of the initial AI applications that you see in the market that have like huge return on investment already is going to be like customer support agents. You'll see this all across like everybody. There's some negatives, but almost every company is rolling out like AI agents, and it's because the data of chatbots is like very set to what the AI needs. So you could literally run a vectorized search across like multiple conversations that the AI that your agents have handled in the past, and say literally here's 5 examples of exactly how to handle this type of situation, and then it can make a decision on what to say. And it does that very effectively because the data kind of fits that format.
Now,
right?
one thing I want to add in though for consideration is from the sort of techno optimist standpoint, I agree with that, but also we're starting to see as these generative AI chatbots are rolled out with the capability to perform RAG on knowledge bases, document stores, like relevant customer support materials. McKinsey, I believe, just released a study recently that reported that upwards of 70% of customers still are finding AI interactions as unsavory or ineffective. So although the technology is advanced in a way that enables us to use these tools to do such a thing, there's still going to be an inherent tension between what people are expecting them to do, or what a human might be able to do to build bridges around knowledge for them, versus I think what we've talked about tons of limitations with RAG and where it can fall short. So OC, I think that was a great explanation, great demo. And I want to kind of open up the discussion as we sort of are approaching the latter portion of our session today, to kind of bring up some final thoughts around, based on everything we've talked about so far with RAG, is this a product offering? Like, is this something that people can it be its own product, or is it more of a feature in this context, right? Where will every AI product need some form of retrieval augmented generation?
Yeah. So I do I want to. Is there a chance I can just kind of though touch on something that someone from the audience brought up immediately?
Yeah,
Please.
there's a really great
Absolutely.
question in the audience.
Yeah, it's
Yeah.
just really good. I wanted to just summarize because the question is how, is the overall workflow in order to, achieve a goal based on like yes, what this workflow achieves in the final step. So we have a desire. And if I could just kind of take a step back and say, for DIY, you want to do it yourself, you want to get in, you want to get involved, you want to learn the RAG, what does it mean? So first of all, you need to identify the things that you want to later on retrieve, right? So it could be a library of PDFs, it could be, as I said, novels, it could be your chat log history, it could be anything, any data that you want to put into a prompt at some point in order to make the LLM smarter about that particular topic. You gather that information, clean up as best it can, because of course, we know that you got the garbage in, garbage out, the oldest problem in data engineering. So you want to clean it up so it's nice, the data as best you can. And then you decide, how am I going to store it and how I'm going to retrieve it? Vector databases are the way we've been talking about. I'll talk later on about other ways of thinking about RAG, but you decide the toolkits. There are many open source vector databases out there you can use for free. Chroma and Quadrant and Pinecone and Wheatley, etc. Our demo used Postgres as SQL database just because we're so used to integrating with enterprise warehouses. So we just kind of cut straight to the source, but you don't need to.
The other advantage there is that it's very easy to inspect it. As mentioned, any standard issue Postgres tool can go in there and you can actually look at it, which is a nice bit of transparency versus a lot of the very highly integrated solutions. That being said, the highly integrated solutions are great. I particularly shout out Chroma for being just like dead simple to use and very nice to use.
Mm-hmm.
Yep. And then you just write a bit of code, or there are products out there. There are many products out there already, which will do what that notebook was doing, where you just put that info out there, you clean it up, you put it, and then you say, hey, I would like to be able to retrieve from this basis of information to answer questions from the LLM. You pick an LLM, whether you're hosting something open source and local, or you're using OpenAI or Claude or whatever. And then a lot of them have integration points, and then you basically figure out what are my processes, my rules, my parameters, how am I going to go about picking from the stuff that I've chunked, sending that information to the LLM and saying, hey, use this additional context to answer this prompt. So I don't want to pretend that there's just like one straight line path. To me, adopting RAG is the beginning of engineering. It's not the end of engineering. You have a lot of work to do once you've adopted RAG, but that work that you have to do is actually really fundamental information to what you're trying to do with that in that product context, which takes me back to what Eli was saying. In the context of an AI product, where does RAG fit in? Is it sort of its own product, or is it sort of a feature? And I'm curious, what you guys think about that.
So I was thinking about it more from like a perspective of like for a developer, or like for the kind of context we've been talking in. Like in terms of if RAG is a product, like I think of it more as like a paradigm or like a set of patterns that people are following, much more akin to like, I don't know if you guys are how familiar everybody here is with web dev, but like there's this concept called the jam stack, or previously like the lamp stack, etc., which is an acronym of the different technologies that you use. In this case, it's just a fun, catchy name like RAG. Like, okay, I guess everyone needs a RAG sometimes. Like, okay. But at the same time, like what it really is it's that confluence of like different technologies that in some cases didn't even exist 10 years ago, right? And specifically that's like vector databases, LLMs, and we could branch off all day on different parts and components of that stack that you could choose from. So ultimately, I think that there is like a need for a product in some sense. Like you might have somebody that like integrates all these sources or these different things for you and hosts it and does it. Like there's a managed services piece to it, but I don't think that there's really like I don't think that it's the innovation is that everybody is doing it and the patterns are developing. It's not so much that there's like one killer feature to it. I think that it's where it could go and where it's headed. That's the most exciting part.
Yeah. And so if I may, I think, as a traditional designer, relatively intermediate software engineer, the perspective that I tend to come at this question about RAG being a product versus a feature is to come back to the problems that it's hoping to address. And the way that, I've seen this emerge for all of our clients, over the past year is they describe it as a desire to connect knowledge. And so that's the primary objective, right? And so I believe, to the LAMP stack or the Jamstack point, that RAG is just one aspect of a broader stack that is worth mentioning, right? Whether recent white papers are showing that some combination of RAG and fine tuning outperform RAG itself, right? And so I think we're going to learn more and more, in that stack of pre-training, applying RAG type techniques, knowledge graphs or citation graphs, getting into fine tuning. There's going to be a broader arc here that will be required to effectively connect knowledge from previously disparate sources. And so, I mean, my take on it is I think everybody's going to be using RAG. I think everybody is going to leverage it as like a simple provider. Like, think about how innovative Stripe was for just 3 lines of code, right? You got billing set up, for example. Like, I think somebody's just going to have a killer library for RAG that just boils down to like a very simple set of components. But it's going to have to be a part of connecting knowledge across disparate sources in a way that meets someone's expectations. And so it's a feature of solving that problem,
right?
I think.
Yeah, and I would say like the fine tuning versus the RAG debate, I find that so many people are having way too early in their conversation. Like, I think that like whether it's RAG or it's fine tuning, that's more a function of how much a GPU chip costs to build than it is about anything else that you might do, right? Like, fine tuning could be better in almost all cases, but it's wildly expensive. And there are ways to make it cheap, but then that's complicated. Like, it's a whole thing. Like, I'm into it as a hobbyist, but I just don't think it's like a good business strategy in that case.
And you know that, yeah. The debate you should be having first is what type of RAG you want to do, because I see RAG is really an umbrella of different strategies that, like, there's simple RAG, there's RAG with memory like Redis, there's HIDE, there's hypothetical document retrieval. So like there's a whole bunch of different ways that you can do this. So it's hard to say that it's a product, because like a client will come to you wanting their specific data to be retrievable. And so that's kind of a strategy among many other strategies that you have to provide for them. And that's how I see it.
Definitely.
So we've got another question coming in that I think is really interesting of, what are RAG or LLM use cases for businesses that we're seeing that are generating revenue rather than just optimizing or reducing cost? Does anybody have? Yeah, Jake, go ahead.
Yeah. I think a really good one is data extraction. So there's a lot of messy data out there, whether it's I don't know, the laws published by your local legislature, or just information that's out there. The long body of auto or aircraft managers, and we've actually done some projects with and seen some startups who there's been a long-standing issue of how can we again take old knowledge and old documentation and old material and make it relevant to today. It's especially important when you have a needle in the haystack problem, right? You've got some old piece of gear which you don't use every day, so no one's going to be like fully dialed into everything that's in the manual. But every now and then you got to figure out, how does this one widget work over here? And again, it's buried in, somewhere in 50,000 pages of total documentation. So by pulling that information, bringing it into a RAG context or within a RAG system, being able to do one of two things. But sorry, I mentioned the data extraction. So let's go with the data extraction. Now you build a cleaned up, modernized, relevance ranked information base that you can sell. You can now take that information base that came from all this vast quantity of information that nobody was going to digest by themselves. You're using RAG basically to help automate the process of digesting that. Now you can sell that, really easy to use and really easy to query data within the industry where that information, really levers business or levers against business problems. And we've seen people make a lot of money with that, just basically using very straightforward RAG approaches.
Jay, can I build off that? Because I think that mine is actually like a subset of yours. That was a great generalization of like where you can make money with AI. because mine is like specifically around like AI dev tools and like coding, right? Which is a very similar information retrieval problem, right? Or information extraction. Because at the end of the day, what you want to do is like, well, actually, I'll call it a very specific subset to answer like the revenue generation point, which is that like there are a lot of tasks that like a dev is required to do in a day-to-day basis that requires them to just simply consume a lot of content. Like, oh, I just have to read all these different things to answer this one question, right? So kind of going back to my reading comprehension test example for earlier, like a lot of times devs are like, oh, why is this line of code broken? And you have to go and read 16,000 files. I know that's dramatic, but you know, it feels like that because it's different than what you want to be doing, right? And we've been using a tool on our team called Cursor that allows us to like that as it's an AI generated dev suite that kind of merits its own episode and how we use it. So I'm not going to go too in depth. But one of the things that it allowed me to do recently was like I needed to dive into this database schema I'd never seen. I needed to add one property because I knew it needed to go somewhere, but I couldn't figure it out. And I asked it to consume in one of the large context models. So like there's a GPT 128K token one, and you can ask it to just consume a folder of your entire database schema and say, hey, where should I put this? And it'll walk it through with sources directly to the file that it's mentioned and defined in. So you can actually go validate what it said, right? And that alone saved me like 3 or 4 hours, right? And so while that still sounds cost cutting, it was funny. They still wanted me to do something else during those 3 hours. It wasn't like I stopped working. So in a way, I'm getting more done. I'm losing less time. And when you're in a technology company, like those coders are ultimately like that's the assembly line of your factory that puts out stuff. And so like if you get that thing moving, like then it is revenue generating in so many different ways and allows you to explore many different things, right? So I think that there's like that task alone would have taken me 4 hours. And if you charge an hourly rate, you could go back and watch how much the request cost, even paid through Cursor. And like Eli did call it out as elaborately expensive when we were looking at our bill recently, but it was like 30 cents, right? And my time is not worth 30 cents for every like 3 hours or whatever, right? Yeah, I feel like there's a very clear arbitrage there that could be taken by someone like Cursor.
And to that point, I think with this question of what use cases for businesses, that generate revenue, I think that's inherently asking the like solution looking for a problem question. And I would instead encourage you to always flip that on its head and identify like areas where your customers are experiencing repetitive pain points at a high frequency. So in the case of like the engineering example, right, every day you're hunting through file structures, patterns, making sure you're making the right decisions, adhering to, your standards, etc. So that's a high pain that's at a high frequency of occurrence, such that employing a RAG type approach actually saves a compounding amount of hours. And so I really think that combination of like looking at your business model, like with intent, interviewing and discussing with your targets where their pain points exist and at what frequency they occur. Most often, pains that occur frequently are a relevant RAG application, which is an interesting to consider.
Yeah. Well, I think that makes a lot of sense though too, right? Because like as we talked about earlier with like customer support, having the data set up in a way that it actually works better for RAG, like you see that like you'll see that across like business problems or markets that are very similar across all types of companies or most types of companies or a large subset of enterprises. So like that's customer support, that's accounting, like you'll see a lot of that stuff now. But I think that as like people start to think in the paradigm of AI and LLM specifically in this case, like they'll start to structure their data and start to transition their data from this structure to a more semantic format that's going to lead to much more revenue generation opportunities than like you're thinking that people are seeing now. Because like right now, cost cutting is just the low hanging fruit of AI. Because a lot of what it does is like systemized or like templated on purpose, basically, right?
So I just want to point out that we're nearing time. So Uche, if you'll make your last Make
Yeah,
your last
just
comment on this, and then I'll do a little bit of wrap up for us.
yeah, absolutely. Last comment. I think basically it's worth thinking that AI of all sorts is it's in its inception, and in terms of how will it how people make money with it and how will it save all sorts of things, productivity costs, etc. It's emerging, right? So you're probably that's why we need to get in, do it yourself, get our hands in. It's clear from this conversation there's so much more to cover with RAG, so we'll be back on maybe more focused topics on RAG, right, Eli?
Definitely, yeah. I think RAG warrants a broader exploration, especially even around providers that already exist in the space. The amount of funding going into orchestration platforms is really important, I think, to just keep a finger on, because as we mentioned, it's a part of a broader arc, a broader story. But, and to OC's point in the chat, as us being DIY and really focused on getting hands-on, being makers, creators, there's all kinds of avenues to get started, whether it's a bougie, PT up at ori.dev, or even looking into other solutions out there that we've mentioned in this conversation. We'll be back again next week. Our goal is to really try to show hands-on examples, help you get over that barrier that may be preventing you from experimenting with these tools. We've had the growing pains, having been in this space for a year and a half now, across all of us. So our mission with AI DIY is just to bring together a group of people, the audience, to talk about interesting AI applications and what's happening in the space, but do it through the lens of you can do it, right? And if you want to be a part of this movement, if you want to kind of join, it's easier than you may assume. And there is a community of people out there willing to help you get into generative AI. So thank you all so much for attending today and joining the session. It's been a pleasure. And this is honestly the highlight of my week every week. So thank you so much for collaborating on everybody. And bye-bye for now to our audience. The episode will be up on Spotify here within the next few hours. And we hope to see you next week.
Thanks
Bye-bye.
all. That was awesome.